Welcome to EDU World Space.
So here in this problem we are given that a man tries to support a stack of books by applying a horizontal force of magnitude 120 Newton, and the mass of each book we are given as 0.95 kg, and the coefficient of static friction between the man's hand and the book we are given as 0.6, and the coefficient of static between each book we are given as 0.4, and we have to calculate the greatest number of books that a man can support. So we'll be drawing the free body diagram first of the two books at the verge of sliding. So this is the free body diagram, and 120 Newton is the force which is applied by the man. Now friction force that would be acting between the two books would be Fb, that will be equals to mu s b times the normal force, that is n. So this value we have 0.4 times n, we have 120 Newton. So from here we'll get the value as 48 Newton. So this is the friction force acting. Now this is the Fg force, that is the gravity force, and this will be equals to n times mg, where n is the number of books. So we can equate the forces in the y direction to be equal to 0. So we can say that sigma Fy will be equals to 0. So the vertical forces acting are the two friction force, that means 2 times Fb, we have 48 Newton, minus n that we have to calculate, times m we are given as 0.95 kg, because the mass of each book is 0.95 kg, times 9.81, the value of G is 9.81, equals to 0. So from here n comes out to be as nearly 10.30, but the total number of books that can support by considering the two books also, it will be equal to this value plus 2, that means 12.30. So it cannot be, the number would be an integer, it cannot be in decimal, so n we are taking it as 12. Now next let us consider the free body diagram of the two hands, and we are considering that the books are on the verge of sliding. So in this case friction force acting would be Fh, and Fh in this case would be equals to mu s, this is, we have to take it for hand, the static friction, times the normal force. So this value we have 0.6 this time, times n is same, that is 120 Newton. So from here we'll get the value of Fh as 72 Newton. Now next we'll be considering the same condition, that is sigma Fy equals to 0. So 2 times Fh we have 72 minus this is Fg force, that is the gravity force. So again we are taking that the number of books, let it be capital N this time, times mg. So n we have to calculate, m and m we have 0.95 kg, times g we have 9.8 meter per second square, and it will be equals to 0. So from here the capital N comes out to be as nearly 15.45. Now we have obtained two values for n, that is 12 and 15.45. So the real value would be the minimum of these two values, that is 12. So n would be equals to 12. Thus we can conclude that the greatest number of books that a man can hold is 12. So I hope you have understood the problem. Thank you.